Okay, let us look here, and what we have here is we're going to be talking about how to do a randomized experiment and the steps on how to do that. Um, so here we go. Let's talk about this right here, and this is our second example. We have a group of researchers in Africa find a creative way to protect cattle from lions. Oh, cattle from lions. They paint eyes on the cow's rears. That's interesting. To determine if this treatment is effective, they randomly assign the cattle to one of the three treatments: eyes on the rear, cross marks on their rear, or nothing on their rears. That is cool. After 4 years of roaming the plains, the cows with eyes saw no deaths. The cows with cross suffered 4 deaths, and the cows with no marks suffered 15 deaths. Well, what we're going to do is explain why it is important to have a control group that didn't get a mark on the rear. Well, the reason why is because if you want to do a comparison, you wanted to see if there was definitely a difference between eyes in the rear and cross marks in the rear. But specifically, is there really a difference? Does this really make a difference if you didn't have anything at all? And so really want to be able to compare effect of having markings on the cattle's rear. Right? Does cattle's rear. In order to do that more effectively is that you have to know if there is a difference, if there is none. So be able to compare the effects of having markings on a cattle rear, cattle rear. Need to have a baseline to determine what the effect is if there were no markings. Okay. To see if the reduced deaths were possibly they're caused by markings on the rear of the cattle. All right. So hopefully that made sense to you. So be able to compare effects of having markings on the cattle's rear. Need to have a baseline to determine what the effect is if there was no markings. All right. There. Need to have a baseline to determine what the effect is if there was no markings to see if the reduced deaths were caused by markings on the rear of the cattle, or I should say, or not. Okay. That's what we're trying to do, cause and effect, all right, with the experiment. So suppose the researchers had, all right, 1,200 cows. Describe how to randomly assign the cows to each treatment group. Well, we want to divide these into into 3 different treatment groups. So if we want to divide this into 3 different treatment groups, we probably want to have 400, 400, and 400. Okay, 400. And so each one of these 400 are going to be assigned to a certain treatment. So we want to randomly assign, all right, 400 to possibly no markings, possibly one with the cross, and then with the 2 eyes, okay, 2 eyes. And so how we're going to do that is going to randomly assign. So we'll first off label all cows, 1 to 1,200. All right. We will then use a random number generator notice that what we're doing right here is we're basically going through how we would do an SRS if you did a surveying or a random, simple random sample. And so we have our sample, but now we're doing random assignment. So random sampling and random assignment are very, very similar, at least the first steps you have. So we're going to label all the cows 1 to 1200. We're going to use a random number generator to select 400 cows or 400 unique numbers. All right. These numbers will assign cows to, you can say to what other treatment you want. So if we want to go to cows to eyes to treatment eyes and rear, eyes in rear. Another, okay, or you can then say the next 400 unique numbers will be assigned to what? Cross marks on rear. Cross marks on rear. And then the remaining cows, will be assigned to, you know it, will be assigned to no marks. Be assigned no marks. And actually, this is what we call our control group. So that's our control group right here, the one with no marks. So that will give us our baseline. All right, and that's how we would randomly assign. So we label all the cows 1 to 1200, use a number and select 4 unique numbers. These numbers will assign cows to treatment eyes and rear. The next 400 unique numbers will, next 400 unique numbers selected. Let me put that there. Ugh, that is not good. Next 400 unique numbers selected. There we go. Unique selected numbers will be assigned to crossbars and rear. The remaining cows will be assigned to no marks. That would be a control. All right, so now let's continue on. What is the purpose of randomly assigning treatments in this context? Well, reason why are we randomly assigning? And so we are not, we can have a general population, and so we are not influencing these cows in one way or another, and so each has the same chance of being selected to either treatment. Okay, so that's why we were doing a random assigning to treatments in this context. Make sure each treatment group is generally the same, okay, or similar. And that's why we are doing that, because we don't have any special cows in one over the other. So just random assignments so that generally each treatment group, I should say each treatment group is generally the same. And that's what we have there. That's why we always do random assignment or random selection, is because we want to have a generalized population of each one. And then finally create an outline showing this complete randomization. Well, I started this outline above, and so essentially we have 1200 cows. So from these 1200 cows, we're going to do a random assignment. All right, so I'll just call it RA of 400 cows to a treatment. And this treatment right here is going to be eyes. All right, and this random assignment is going to be 400 cows to the treatment of crosses. And then our random assignment here is going to be 400 cows. Oops, not 4,000, 400 cows. Okay, to no marks So our treatment right here of our cows is treatment is no marks, and yes, this is a treatment. All right, is no marks. Okay, and then from here we're going to compare deaths. Okay, compare deaths in the end. And so that's what we're going to do right there. And then we can see what the deaths occur after 4 years of roaming the plains. Cows with I had no deaths. Cows with suffered 4 deaths, and cows with no marks suffered 15 deaths. Okay, so there was a difference, and later on we're going to say, is that significant? Is that statistically significant? That's what we have to kind of decide, and we're going to talk about that later on. All right, so here is how we do assigning of treatments, random assignment, and why we use controls, and so on and so forth. All right, I hope this helps you out, and good luck, and God bless in the rest of your problems.